Hello everyone, I'm Vedant and I'm excited to show you the demonstration of our prototype for AI load consolidation and optimization engine. So currently I'm in my dashboard of the prototype where I can see the entire analytics like the pending shipments, the fleet vehicles, the depot departure locations and the total reduction in the costs. So along with the different parameters like the CO2 carbon reduction, the trips estimated, the cost savings, average utilization, the utilization trend and the different activities. So I'll start with the demonstration from the shipments. As traditionally, the dispatchers had to manually assign the city origins destination for the particular shipment, and by considering the weight, volume, and the route, it would mean less efficiency in the route calculation. So in our ship in our algorithm, we calculate the best way to optimize this. So for example, I'll add a shipment from Nashik to Mumbai city with a weight of 1000 kg and volume I can calculate from this example and take the default and 120. So this is the preview of my package. I'll keep these things as normal like the priority. If it's critical then it will be given high priority and the cargo type, and I'll keep the date as it is. So my shipment is created. Here you can see the status as pending. There are four different status. Like the pending status, which means the shipment is ready for being consolidated. The consolidated, which means the algorithm is implemented for that. And in transit, the shipment is transported or is being transported rather and is delivered. So the shipment has reached its final destination. So you can see the different priorities and I'll run AI engine for this example. So I will run the consolidation for one shipment and our customized AI model has properly calculated the route and the shipment cluster. So I can see the cluster here. The Ashok vehicle is being assigned, and as per the vehicle, I can view the shipment and even modify and select another vehicle. Currently, I have 11 vehicles in my settings. I'll show you that. As I can see, it's being transported. Now, if I come to setting, I can see my vehicle fleet. Here are 12 different vehicles, and this is archived. So I have total 11 working vehicles, and in that, Ashok is in progress. So as Ashok is in progress or is being transit, so it can be assigned for different cluster or different shipment unless it's being delivered or forcefully released or recalculated by the manager itself. Now I can see the different departure locations. Currently, the main departure locations that we have considered is Mumbai, Delhi, Bangalore, Chennai, Kolkata, Ahmedabad, Pune, and Hyderabad. So depot locations where the vehicles or a vehicle fleet would be present. So I can even add a new depot. For example, I will select Nasik city, Nasik main depot, and I will select the city as Nasik or to fetch the coordinates. Here, these coordinates are mapped from our algorithm. I can verify this Nasik latitude and longitude 20 and 73. So here it's 220 and 73. So it's accurate. So coming back to the consolidation engine, as Ashok is being assigned, the total shipment is 1, the weight is 1000 kg, the total distance is 286 kilometers, and cost is this much. The load distribution is like this vehicle can carry up to 1000 kg. Now I can see the optimized routes. So we have properly implemented the load along with the route optimization. Now I'll focus on this and show you this the plan. So Ashok vehicle for this cluster, it has one pickup and one delivery along with the Mumbai depot as the start where Nasik has the pickup location coming back to Mumbai delivery, and the nearest depot is Mumbai. Total distance is 287 with estimated time of 4 hours 46 minutes and cost is this much. Our route calculation uses a strong modification of Google OR tools along with the optimized or the best out of shortest path algorithms of Dijkstra and A-star. Here, the best route between two cities is being calculated along with the actual map estimation, like the actual national highways which are being considered. You can see the expressways. Here, the vehicle goes to Nasik and comes back to the Mumbai with pickup and delivery. Currently, I have used a single example and I will show you with the multiple example. And now, currently, I will just delete this and upload a larger example which covers the entire geography for India. Here, this is my CSV which consists of different cities along with different weight shipments or weight of the particular shipments and the different priorities. Here, if there's any missing value, then AI will suggest to fill that value. So I have added these things and I have 11 pending shipments. Now I will run the AI engine for all. So The AI model which we have trained is based on the DB scan, which is a modified k-means algorithm, along with the first fit for delivery in decreasing way. Now, the different estimation is like the CO2 emission before and after, and to proper utilization. So, for a larger example of different cities, large cluster is being created of 4 different vehicles, where a chain route refers to 2 different routes merged into a single one, where the total weight, total cost estimated is being calculated. Now, here are different shipments which were present. In my example, there were 11. So we can see the 4, 4, 8, 9, 10, and here 11. So 11 proper shipments are distributed. I accept all of them, and I can see the shipments are in transportation, and I can see these vehicles can't choose different location, as if as these are in transition, so these vehicles can't be assigned to different shipments as these are busy. So coming back to consolidation, I'll see the optimized routes, and I can see 4 different vehicles having 4 different routes. Starting with Mahindra, I can see it has the route from start destination as Hyderabad and end at Kolkata, with pickup at Hyderabad and 3 deliveries at Kolkata, along with that route added to pick up in Hyderabad and delivery at Kolkata. Now 4 different routes here from Delhi to pick up 2 shipments and delivery at Mumbai for 2 shipments. Then for the third one, it's for Bengaluru to Chennai for these different shipments. And lastly, from Pune to Ahmedabad for these shipments. I can even see the detailed route for this particular. Here it shows the total distance, the total number of pickups, deliveries, and different routes like National Highway 48 and all. Now, the mainly algorithm for the 3D packing, as this is the most optimized way to cluster. I can select a particular cluster and see the optimized packing. For example, for this cluster, you can see different 4 shipments. Here, the first way decreasing order is being selected, and with that, the best optimal way for the delivery personals or the transport shipment managers can understand how a particular package or shipment can be loaded in the particular container. For example, for this Bharat Benz, it was able to explore these shipments. You can see the different perspectives here, the different animation, front, back, left view, right view, top view, and inside view. And I can even see the container details. I can report or see the print. I can see the particular weight, volume distribution, like based on volume and weight, how it's been calculated, the algorithm which it involved, computation time, the free space present. I can even change the settings for the view. I can see the exploded view. You can see the heat map. I can stop the rotation, the loading order, the center of gravity, dimensionality rulers. I can even change those if I don't want. Then I can see the animation again, and I can choose for different vehicles. For this was cluster 1. I can see the optimized packing. For cluster 4, what's the optimized? For cluster 3, you can see all the shipments have been covered. Now, coming to the simulator, we can see the simulation on how these strategies work together properly and how they calculate the costs. I can see the working animation, the weight reduction, the algorithm, which is hybrid as a combination of different things. The consolidation would lead to this AI optimization and custom configuration. So I can see the matrices visually with the performance data. Then I can see the carbon impact that our project has been created. This is the total summation of all the things that we were able to save. The total cost based on different trucks, vehicles assigned, and all the matrices, like the ESG scoring. Now, finally, the very strong point that we would like to mention is the AI agent. For example, in my project, if it's difficult to understand by any non-technical person, he can understand and chat with the AI agent, and it will do all those things that we have seen up till now in just an agentic way in the screen itself. For example, I'll add a new shipment. For example, in Nagpur to Kolkata with a weight of 1000 kg, and I can even check 100, or I'll take the default. So this is my package, and I'll keep this as, and I can chat with the copilot. What are the pending shipments? So there's one pending shipment I can see here. The starting location is Nagpur and destination is Kolkata. It was able to fetch from my shipments. So I will run the consolidation engine here and itself. So AI will show how it worked, the trips, cost saved, CO2 reduced, and average utilization as it was assigned to Ashok with total 100% utilization. And I can even see the entire routing map. So the starting destination was Hyderabad. It went to Nagpur for package pickup and went to Kolkata for delivery. So currently, due to time constraint, I'll just skip this session, but you can explore all these things available. Finally, you can download or generate any reports. A sample format would look like this: a complete history of all those things that were happening in the database. So if it's still difficult to understand, you can explore the entire documentation, the entire shipment engine, how it works, and the core algorithms like DB scan model that we created, the 3D being packaging, vehicle routing, CO2, the agentic pipeline R model which we created using different mixture of experts. And then we use feedback learning. So if we change anything, the AI would understand and it would not repeat the same mistake again. This is the system architecture, the tech stack, and if anything that you need to view. Lastly, the database that we use was Supabase as a structured database where all these things are dynamically stored and the backend is deployed. The entire models are deployed in the render and front end we use Vercel for Next.js deployment. Thank you so much. If you have any suggestion, please feel free to reach
Hello
us out.
everyone. Did you know the logistic industry loses billions of dollars annually due to half-empty trucks and inefficient routing? So this inefficient doesn't just burn money; it burns fuel, contributing massively to unnecessary carbon emission. We, our team, Escape Velocity, and we have built Lorri, an AI-powered logistics optimization and consolidation app, which is an engine where Lorri intelligently consolidates shipments, maximizes vehicles capacity, and significantly reduces operational cost and carbon footprints. So let's see APPD. Okay. So what exactly does Lorry do? Our engine is driven by five core features. So the features are intelligent consolidation using machine learning. Lorry automatically groups geographically close shipments. Capacity optimizations. Our algorithm ensures every inch of a truck is used efficiently, minimizing wasted space. Route optimization. We calculate the absolute best delivery paths to save time, distance, and fuel. Our USP 3D load visualization. We generate interactive 3D simulation showing warehouse planners exactly how items fit inside a specific container. AI Logistic Copilot, a natural language assistant that lets manager converse their supply chain, asking questions like "Show me underutilized trucks today." So it gives you a specific answer. So let's talk about an architecture. So how does this work under the hood? The flow is highly streamlined. First, the data ingestion, shipment data like weight, dimension, and deadlines enters the system. Next, our Python backend takes over. It clusters the shipments, runs bin packaging, algorithms to assign them to right vehicles, and solves the vehicle routing problem to map the journey. Finally, this optimized data flows securely from our Superbase database to Next.js frontend, where managers interact with 3D models, live maps, and AI Copilot. So the tech stack that we have been used over here is we have built this robust engine using an advanced open source stack. So the front end is powered by Next.js, Tailwind, and 3.js for our 3D modeling. The backend relies on Python, Flask, Google OR tools for optimization algorithm. Then we have used scikit-learn library of machine learning for the clustering purpose, and the Mistral LLM for our intelligent copilot. So the business value and revenue growth. So here we can talk about the let's talk business. Lorry isn't just a cool tech prototype. It delivers massive ROI by increasing vehicle utilizations by up to 40% and reducing empty miles. Fleet scan slash logistics cost by 20 to 30%. So our revenue model is scalable B2B SaaS subscription based on shipment volume. So we offer a tiered pricing, a basic plan for small fleets, a pro plan for mid-sized companies, and custom enterprise contracts. Because Lorry saves companies far more money than it costs. So client retention will be especially high. So furthermore, by reducing carbon emissions by 25%, we help companies meet strict ESG sustainability goals. So making our platform a regulatory necessary, not a luxury. So, in short, Lorry makes our logistics smarter, greener, and highly profitable. So, we are ready to modernize supply chains and eliminate the massive waste of empty miles once and for all. So thank you, Judges, and we do love to answer any questions, and we are